Again, to write this as a piecewise function, we need to establish when the domain is positive or negative. So the first thing we're going to do is we really want to know whether inside is going to be equal to 0. So to find out when the inside is going to be equal to 0, I really should factor this. So I'm going to factor this to minus 3 plus 1. Okay, so then I know that this is a parabola where I need to establish the 0 part of it at positive 3, negative 1. And then I need to determine in which regions is it going to be above 0 and below 0. So there's positive 3, negative 1. And one way to visualize this is, and we could just test some coordinates by plugging in. So for example, I can plug in 0. If I plug 0 in, I get negative 3 times positive 1 is negative. And we know that in this region here, we're going to be below the x-axis, okay, or below 0. We're going to be negative. But we could also establish that same concept or same idea if we just visualize that this is a facing up parabola. And we know that from here to the left and from here to the right, we're going to be above the x-axis. So that's how I'm going to establish my domain. Okay, so that's going to be my positive domain, and below is going to be my negative domain. I'm actually going to switch the colors here. Okay, so it's going to be above the x-axis over here. Okay, and then it's going to be below the x-axis down here. So just going to shade that in a little bit darker. So between here and here is going to be below the x-axis. So that's how I establish my domain. So writing this as a piecewise function, again, I have my positive domain. The positive domain is going to be expressed for x is less than or equal to negative 1, or x is greater than or equal to positive 3. So when that is the case, then I'm just going to have the equation x squared minus 2x minus 3. For the negative domain, it's going to be the opposite. The negative domain is going to be when x is between negative 1 and positive 3. When that happens, I need to take the x squared minus 2x minus 3, and I need to make that negative expression in here positive by using that negative here. Okay, so that makes it positive, and now I have the absolute value. That expresses it as a piecewise function. So just sketching what this graph would look like. This one happens to have zeros on the x-axis. Okay, it doesn't have to bounce on the x-axis, but this one does because there's nothing on the outside. So I have my zeros at negative 1, positive 3 here. On the outside, it's going to have just a regular right side up parabola. And on the inside, and if I simplify this, this is going to be negative x plus x squared plus 2x plus 3. It's going to have a y-intercept up here. It's going to go upside down parabola in that region. Okay, so outside there, that domain, it's going to continue like this. Outside the domain, it's going to continue. Oops. It's going to continue like this. Okay, but the part that's solid is a part that represents the graph. So solving equations is the same thing. We still need to consider the positive and negative versions. So I have to consider the positive value. The positive domain is when x is going to be less than or equal to 5. Okay, because as x gets smaller, that remains positive. And if that's the case, I'm solving the equation 5 minus x, that positive value, is equal to 9. solving for x, I get 5 minus 9. And I'm going to add x to both sides. So x equals negative 4. Okay, so that's going to be in the positive version. And again, we can check for extraneous solutions, and we should. We can always check for extraneous solutions by substituting, but we can also check for extraneous solutions by comparing the domain with the solution, and the solution fits in the domain. We then need to consider the negative version of this solution. Okay, so the negative version is going to be the domain when x is going to be greater than 5. So when x is x is greater than 5, we know we have the negative version. Well, if I have the negative version, that 5 minus x, I need to convert to positive with that negative on the outside, and that's equal to 9. And I can solve this equation. I'm going to add 5 to both sides, and I get x equals 14. Okay? And that is the positive version, and I can check for extraneous solutions by testing that solution on the domain. That solution fits in that domain, so that's a good solution. Okay, so these are both good. These answers are both valid solutions. And again, I could always do this by testing. I can do my test. I can test x equals negative 4 by plugging in 5 minus negative 4, absolute value equals 9. Well, that's true. That's why that one works. I can also test x equals 14. I get 5 minus 14, absolute value equals 9. That one also works, so both of those solutions are valid solutions based on our check for or test for extraneous solutions.